Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 25, Episode 142, for broadcast on the 30th of December 2022. Coming up on our final SpaceTime for the year, NASA's Perseverance rover to start setting up a Martian sample depot, a new satellite launch to monitor all the world's water, and China sets a new record for the number of orbital launches conducted in a year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Perseverance rover has started work setting up a Mars sample return depot on the Red Planet, the first to be established on another world. The project marks an important milestone in the joint NASA-European Space Agency Mars Sample Return campaign, which aims to bring Mars samples to Earth for closer study. The depot building process starts when the rover drops one of its titanium sample tubes carrying a chalk-sized core of rock from its cache at a location within Jezero Crater, which has been nicknamed Three Forks. Over the course of 30 days or so, Perseverance will deposit a total of 10 tubes carrying samples representing the diversity of the rock record in Jezero Crater. Since its arrival on the Red Planet, the rover's been taking a pair of samples from each of its rock targets. Half of every pair will be deposited at Three Forks as a backup set, and the other half will remain inside Perseverance's cache, where it will be the primary means of conveying collected samples to a Mars Ascent vehicle, a small rocket which in coming years will be sent to the Red Planet to retrieve the samples for transport back to Earth. Mars Sample Return Program Principal Scientist Minashi Wadwa from Arizona State University says the samples for this depot and the duplicates held aboard Perseverance will provide a valuable igneous and sedimentary rock record of at least 2 and possibly more than 4 distinct styles of aqueous alteration, as well as regolith and atmospheric samples. One of the first requirements for the sample depot on Mars is to find a level rock-free stretch of terrain in Jezero Crater where there's room for each tube to be deposited. Up until now, Mars missions have required just one good landing zone, but with the sample return mission, there'll be a need for 11 such zones. The first for the sample retrieval lander, and the remaining 10 for sample recovery helicopters to perform takeoffs and landings. And of course, each site will also need to be accessible by land for the rover. After settling on a suitable site, the campaign's next task will be to figure out exactly where and how to deploy the tubes in that location. See, you can't simply just drop them in a big pile, because the recovery helicopters are being designed to interact only with one tube at a time. Of course, the helicopters are only intended to serve as a backup, just like the depot itself. To ensure a helicopter can retrieve a sample without disturbing the rest of the depot or encounter any other obstructions from the occasional rock or ripple, each tube drop location will have an area of operation of at least 5.5 meters in diameter. To that end, the tubes will be deposited on the surface in an intricate zigzag pattern, with each sample 5 to 15 meters away from the next. The depot's success will depend on the accurate placement of the tubes, a process which will take over a month. Before and after Perseverance drops each tube, mission controllers will review a multitude of images from the rover. This assessment will also give the Mars Sample Return Team the precise data necessary to locate the tubes in the event that the samples become covered by dust or sand before they're collected. Meanwhile, Perseverance's primary mission concludes on January the 6th, one Martian year, or 687 Earth days, after its February 18th, 2021 landing. The car-sized six-wheel rover will still be working its sample depot deployment when its extended mission begins the next day on January the 7th. However, once the table's set at Three Forks, mission managers will send the rover to the top of the delta. When they get there, the science team want to take a good hard look around. Called the Delta Top Campaign, this new science phase begins when Perseverance finishes its ascent of the Delta's steep embankment and arrives at the expanse that forms the upper surface of the Jezero Delta, probably sometime in February. During the campaign, which will last about 8 months, the science team will be on the lookout for boulders and other material that have been carried from further upstream and deposited by the ancient river that formed the delta. The Delta Top campaign is an opportunity to get a glimpse of the geological processes that took place well beyond the walls of Jezero Crater. You see, billions of years ago, a raging river torrent carried sediments, debris and boulders from kilometres away down into the crater lake, where Perseverance will now be able to explore these ancient river deposits and collect samples. The key objective of Perseverance's mission on Mars is astrobiology, including obtaining samples that may contain signs of ancient microbial life on the red planet. Had it ever existed there, these sediments are likely to have been one of its homes. But the rover is also characterising the planet's geology and past climate, testing new materials for future manned missions to Mars, and determining how easy it is to make oxygen out of the carbon dioxide Martian air. This report from ESA TV.
Hi, I'm Kelsey Brennan-Wessels for ESA Web TV, and I'm joined by David Parker, who is the Director of Human and Robotic Exploration at ESA. Now, David, I understand that you have been attending the Mars Return Sample Conference here in Berlin. You took a break to join us here at ELA to talk about the prospects of a mission that could go to Mars, collect samples, and then bring them back to Earth. First, I just want to ask you, why are we interested in studying Mars?
Well, Mars is fascinating because it's the planet that's nearest to us. It started off with all the same raw materials as our planet, but somehow it's gone in a different direction. We know the Earth is great for life. Everywhere we look on the planet Earth, there's life. The question is, why did Mars turn out completely different, go wrong, get cold, lose its water? What was different about that planet, and what does it tell us about our own planet?
Now, what are ESA's current activities with Mars?
Well, we're very busy with Mars exploration. Our Mars Express spacecraft has been there since Christmas Day 2003, doing great science, looking at the subsurface with a radar, and making amazing images, stereo images of the surface, and also looking at the atmosphere. And one of the instruments there that was looking at the atmosphere seemed to detect a mysterious gas, methane, in a very, very small quantities. And so we wanted to go back with a custom-built spacecraft to look into what we call the trace gases. So we have our ExoMars Trace Gas Orbiter in orbit. It's done 900 aerobraking maneuvers to get itself down to the scientific orbit. This spacecraft also will allow us to talk to our Mars rover. Our Mars Rover project, which is under development and is being built right now. So the ExoMars Rover, what is special about it is it's the first spacecraft designed actually to look for the evidence of past or present life, to be able to rove over the surface, but also to get below the surface. And its key feature is this drill. So it will be able to go 2 meters down below the surface. Why do we want to do that? Because we think that any evidence of past or present life will have been eliminated by the terrible radiation environment we have on Mars today. So we're looking for material that may have been buried there for millions or even billions of years. So it's all very exciting at the moment.
Now, looking beyond this rover, what does the future hold?
Well, the scientists have many, many challenges, and each time we go to Mars, whether it's with orbiters, whether it's with landers or rovers, it just leads to more questions, more unraveling the mystery of, for example, what happened to the water that we think Mars had. Probably billions of tons of water still frozen, maybe below the surface. What happened to the atmosphere? What's the geological history of the planet? We have a plate tectonics which changed the shape of planet Earth. We think Mars froze quite early on. So for all of these reasons, to really get to the answers to some of these key questions, we want to bring Mars back to planet Earth for the first time with a spaceship.
And what are the challenges in a mission like
This
this?
is enormous. This kind of Mars sample return project, it's not one spacecraft, it's almost an armada, a fleet of missions to go there, take the samples, put them safely in special tubes to protect them, launch them off the surface of the planet. We've never done that before. Rendezvous in orbit around the planet, transfer from one spacecraft to another, kind of a relay race, bring it back to Earth, come back through our atmosphere, and take it to our laboratories back here on Earth.
That sounds like quite an endeavor.
It's going to be a kind of a 10-year-long challenge. The first part of that, NASA is already undertaking, getting those precious samples and putting them safely onto the surface of Mars for the next step to come and collect them some years in the future. And so if the whole thing goes to plan, we might have those samples back on planet Earth by the end of this decade.
Well, we'll look forward to that, won't we?
It's a big challenge. All of these science projects go on for years, and the scientists benefit for a long time. You know, we're still using the material we brought back from the moon and learning new things from it. And I'm sure with Mars, we'll learn new answers to questions for the rest of this century.
Well, I hope it does, in fact, provide some answers to our questions. David, thank you so much for joining us today.
This is SpaceTime. Still to come, a new satellite launched to monitor all the world's water. And China sets a new record for the number of orbital rocket launches it carries out in a year. All that and more still to come on SpaceTime. A joint Franco-American scientific satellite has been successfully launched into orbit on a mission to study all the world's water. The Surface Water and Ocean Topography, or SWOT spacecraft, thundered into orbit aboard a Falcon 9 rocket from Space Launch Complex 4E at the Vandenberg Space Force Base in California. SWOT will spend the next 3 years providing high-definition data, measuring the height of water in the planet's lakes, rivers, reservoirs and oceans. This information will provide insights into how the oceans influence climate change, how a warming world affects lakes, rivers and reservoirs, and how communities can better prepare for disasters such as floods. After MECO, or main engine cutoff, the Falcon 9's first stage booster returned to Vandenberg, successfully landing at the facility's landing zone 4, less than half a kilometre downrange from the launch pad, 7.5 minutes after liftoff. After SWOT separated from its upper stage, ground controllers successfully acquired the satellite's signal. Initial telemetry reports the spacecraft is in good health. SWOT will now undergo a series of checks and calibrations before it starts collecting science data in about 6 months' time. NASA Administrator Bill Nelson says the warming seas, extreme weather, severe wildfires and extreme floods are only some of the consequences humanity is facing due to climate change. He says the climate crisis requires an all-hands-on-deck approach, and SWOT is the realisation of a long-standing international partnership that will ultimately better equip communities to face these challenges. SWOT will cover the entire Earth's surface between 78 degrees south and north latitude every 21 days, sending back a terabyte of data daily. The scientific heart of the spacecraft is an innovative instrument called CARIN, the Ka-band radar interferometer. CARIN bounces radar pulses off the water's surface and receives the return signal using 2 antennae on booms extended out on either side of the spacecraft. This arrangement of one signal, 2 antennas, will enable engineers to precisely determine the height of the water's surface across 2 swathes at a time, each of them 50 kilometres wide. That data is essential to better understanding how Earth's air, water and ecosystems interact. Among the many benefits the SWOT mission will provide is a significantly clearer picture of the Earth's freshwater bodies. In fact, it'll provide data on more than 95% of the world's lakes and rivers. At the moment, freshwater researchers only have reliable measurements for just a few thousand lakes around the world, but SWOT will push that number into the millions. Along the coast, SWOT will provide information on sea level, filling in observational gaps in areas that don't have tide gauges or other instruments that measure sea surface height. Over time, this data will help researchers better track sea level rise, which will directly impact communities and coastal ecosystems. The mission marks 30 years of collaboration between NASA and the French space agency CNES in altimetry, which was pioneered by the launch of Topex Poseidon back in 1992. This report from NASA TV.
Right now, I'm thrilled to be joined by Li Luang-Fu, the SWAT project scientist who's been working on water monitoring missions for over 2 decades. Welcome, Li. Can you tell me what are the main science goals of SWAT?
Yeah, the main science goals are to better understand the ocean's role in climate change and how in a warming climate is affecting the Earth's rivers, lakes, and reservoirs. So more than 90% of the heat since the Industrial Revolution, the global warming has been absorbed and stored in the deep sea. SWAT will provide a high-definition view of ocean topography for calculating ocean currents that transport the heat from the atmosphere to the deep sea. So the data will help improve ocean models to assess the ocean's capacity in the future to keep absorbing heat, protect humanity from global warming. And also in a warming climate, the water cycle of Earth is accelerating, making it very difficult to track and manage water resources, and also difficult to predict flood and droughts. So most of the lakes, rivers are not well sampled, but the SWAT for the first time will provide a global survey of the elevation of the lake storage of water and the flow rates of river, allow us to better model and so manage the water resources and predict floods and droughts. This is in a nutshell.
Right. Very good in a nutshell. And I like that you said that this is the first time that we're seeing something like this. So what sets SWAT apart from previous satellites?
Yeah, it's all about the spatial resolution and the coverage. For instance, the footprint of the radar on SWAT is 1,000 times smaller than conventional altimeter, making this spatial resolution of SWAT much, much higher. And also, it will cover all the ocean and the surface water without any gaps between 78 degrees north and the south.
Wow. So we're getting something we've never seen before. And Li, you've been working on SWAT since the beginning for 20 years. What does it feel like to be here for launch?
Yeah, this mission is 20 years in the making, and this is the fourth satellite mission. I serve as a project scientist. So, but this mission is the most complex and challenging, representing the culmination of my 40-plus years career at JPL working on oceanography from space.
The SWAT satellite is truly a remarkable spacecraft. Earlier, I got a chance to look at it up close with SWAT project manager Parag Vaze.
Our brand new instrument called the Karen Ka-band radar interferometer. What makes it an interferometer is really having a radar with signals that are transmitted and received from two separate antennas that are separated by a large distance. We also need other instruments to make SWAT work. We have a radar altimeter, which is a more traditional kind of altimeter, gives us precise but very small strip maps. We have a microwave radiometer that's used to correct the altimeter measurement in terms of the water vapor as the signal is going through the Earth's atmosphere. And we also need a set of instrumentation that tells us a very accurate position of the spacecraft in space itself. We have a GPS receiver, we have a DORIS system, and we have the laser retroreflector array.
And can you let us know how SWAT will communicate?
The key to being able to do that, of course, is we have a very large recorder, memory recorder inside the module here, but then getting it out is the job of the X-band antenna system that's downlinking at 600 megabit per second. And we also have an S-band system that's more for command and control and basic mission operations.
We obviously can't take a SWAT like this in space. How will it fold and unfold after launch?
So the whole system is, of course, needs to be compact. It's folded off to the side of the payload module, and it basically deploys in 3 phases. One that's first coming up, and then moving out, and then the antennas finally deploying on the side themselves, and then the whole system is locked in place.
This is SpaceTime. Still to come. China sets a new record for the number of orbital launches in a year, and later in the science report, the United Nations announces plans to launch a new satellite specifically designed to monitor methane emissions and pinpoint their sources. All that and more still to come on SpaceTime. China appears to have finally wrapped up a busy orbital launch year, conducting a record 62 missions in 2022. And its final flight of the year was also Beijing's 7th in just over a week. The flight aboard a Long March 11 rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province carried the highly classified Xi'an-21 spacecraft into orbit. China claims the new satellite will undertake in-orbit verification of new science technologies. The term Xi'an means experiment in Chinese. The new satellite joins another 2 Xi'an experimental spacecraft which were launched just a few days earlier, this time aboard a Long March 4C rocket from the Zhuquan Satellite Launch Center in northwestern China's Gobi Desert. And like the Xi'an-21, Beijing described the classified Xi'an-20A and B spacecraft as being used for orbital verification of new technologies such as space environment monitoring. However, that's not the view taken by military analysts. They suggest these spacecraft are actually designed for RPO or rendezvous proximity operations. In other words, they're spy satellites, specifically designed to test new ways to monitor or eavesdrop on the operations of other nations' spacecraft. And they'll join the already in orbit 1,200-kilogram Xi'an-20C spacecraft, which was launched into a 700-kilometer high orbit aboard a Long March 2D rocket, also from Zhuquan, back in October. The Xi'an-21 launch took place just 36 hours after the last launch from Zhuquan, which saw a Long March 2D rocket carry another 3 Yaogan 36 spy satellites into orbit. The Yaogan 36 mission patches display ocean waves with shapes resembling islands in the South China Sea, and that suggests the possible focus for this mission is on the highly disputed region which Beijing has stolen from the Philippines, Taiwan, Vietnam, Malaysia, Brunei, and Indonesia. Just a day earlier, China launched the world's first methane-fueled rocket, the Zhuqiu-2, on its maiden flight from Zhuquan. However, that mission failed to reach orbit, losing 14 satellites. Early indications suggest an issue with the launch vehicle's second stage may have been the problem. The failure happened on the same day that another experimental rocket was launched into space by China on its maiden voyage, this time from a ship in the Yellow Sea. The Smart Dragon 3 is a 31-metre-tall solid-fueled rocket capable of carrying a 1.5-ton payload into a 500-kilometre-high sun-synchronous orbit. And unlike the Zhuqiu-2, it successfully placed its payload of 14 satellites into their intended orbits. 3 days earlier, a Long March 2D rocket lifted off from the Taiyuan Satellite Launch Center in northern China's Jiangxi province, placing the Gofeng 5 hyperspectral multifunctional observational satellite into a sun-synchronous orbit 705 kilometers above the Earth. Beijing claims the satellite's equipped with scientific equipment that will be used to monitor ecology, the environment, survey natural resources, farming output, forestry, and atmospheric conditions. However, once again, military experts have a totally different picture. They say it's another military spy satellite, equipped with high-resolution optical and multispectral synthetic aperture radar imagery systems and electronic signals intelligence gathering surveillance technology. Put simply, the Gofeng are designed to provide continuous reconnaissance, monitoring areas of interest to Beijing as part of what Chinese President Xi Jinping and his communist government describe as preparations for war. This intense period of launch activity kicked off a day earlier when Beijing launched a Kuaizhou 11 rocket into space from Zhuquan, carrying the Jingweng Transport VDS experimental satellite. It's tasked with demonstrating very high-frequency data exchange technologies. The 25-metre-tall Kuaizhou 11 is designed to carry a 1-ton payload into a 700-kilometre high sun-synchronous orbit. China now has an estimated 583 satellites orbiting the Earth. That includes over 242 Earth observation, surveillance or reconnaissance satellites, including at least 46 Gofeng and 111 Yaogan spy satellites. The 62 orbital launches carried out by China this year sets a new orbital launch record for Beijing, easily surpassing the old record of 55 orbital launches set in 2021. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. As part of global efforts to slow climate change by tackling methane emissions, the United Nations has announced a new satellite-based orbital detection system designed to police emissions of the climate-warming gas and alert governments and industry. The Methane Alert and Response System, or MARS, was approved at the 27th United Nations Climate Change Conference at Sharm el-Sheikh. MARS will use state-of-the-art satellite data to identify major methane emission events, notify relevant stakeholders, and support and track mitigation progress. A new study has found that replacing a diet full of red meat with chickpeas and lentils is good not just for your health, but also for your wallet and the climate. A report in the journal eClinical Medicine investigated 5 diets, replacing some or all of red meat, finding they could all provide the recommended amount of nutrition, save the health system thousands of dollars per person, and cut diet-related greenhouse gas emissions by as much as 35%. The greatest benefits for all the above were seen in a diet which replaces all red meat with minimally produced plant-based alternatives such as legumes, which also had a 70% lower average grocery cost. And while we're on the subject of food, scientists at Macquarie University and the ARC Centre of Excellence in Synthetic Biology have created a versatile and nutritious new space food specifically designed for astronauts. A report in the journal Nature Communications claims the meal uses a common form of yeast, a 3D printer, and some clever science. The study's authors, or should that be chefs, say the bioengineered yeast-based meal would provide a customizable food supply that provides dishes with the taste, texture, and nutrients of their earthbound counterparts. A new study claims people who meditate are more likely to have strong religious beliefs compared to those that don't. Researchers asked some 3,684 people about their beliefs in the supernatural, a higher being, life after death, and even in the existence of angels. They found that 81% of meditators did believe in a divine being, compared to 57% of non-meditators. But Tim Mendham from Australian Skeptics says rather than people who meditate having strong religious beliefs, it's far more likely that those with strong religious convictions also just happen to practice meditation.
There's a survey done by a company called PsychTest, and they do surveys regularly, and they looked at about 3,500 people, and people who are what they described as avid meditators and non-meditators, and they looked at their beliefs in the paranormal, and so they found things like 81% of meditators believe in God or some divine sort of being, whereas only 57% of non-meditators believed in a divine being. 67% of meditators believe in angels, while only 54% did. Non-meditators, 71% of meditators believe in life after death, whereas only 58% of non-meditators believe in life after death. These are very high figures for non-meditators, by the way, in their belief in religion and the supernatural. So you wonder where this survey was done. You would assume it was done in the US, which has a general high belief in gods and things like that. Certainly not done in a lot of other countries where the belief in gods is a lot lower than 57%. So the question then came up that what they assumed was that people who do meditation open themselves up to other beliefs. And this is like result A leads to assessment B. The trouble is, like a lot of surveys, and this one seems to me be a problem here, is that they're going about it the wrong way. It might be that people who are open to paranormal or religious or spiritual beliefs turn to meditation because it's the sort of thing they do. When you say 81% of meditators believe in God or a divine being, that's a very high number, and you might think that therefore people who are suggestible and who might believe in the paranormal might take up meditation. So rather than meditation opening them up to the paranormal, it's their beliefs in the paranormal that open them up to meditation. In the same way as people who are inclined to believe in the paranormal might go on ghost hunts, real ghost hunts, who might sort of tune in to ghost movies and that sort of stuff. So the question is, you can't say people who watch paranormal movies, they become believers in the paranormal. No, it's the other way. And this survey is saying meditators are open to the paranormal, whereas it might be paranormal believers are open to meditation. So there's a very sort of dangerous thing here which happens with a lot of surveys and a lot of assessments, that you get the wrong impression. I remember a survey done many years ago, sociology area, where it said 90% of kids who smoke muck up in school. Suggestion was stop them smoking. No, the thing is, kids who muck up in school tend to smoke. Right? They're the rebellious or the naughty sort of people, and they tend to do rebellious or naughty things. So therefore, some of these people get around the wrong way, and I think this is a particular case. A lot of people do believe in the paranormal, and a lot of people who believe in the paranormal might be inclined to go to meditation. Don't forget that all of these people, they surveyed, some of them were meditators, so therefore, of the meditators, 81% believes in God. So you think a lot of people who believe in God might go for meditation. Of course, yoga and things like that do have a religious element. Be careful of surveys, in other words.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.